Hi guys, today we're going to learn about conjugates and how to use them to rationalize the denominator. This is a very difficult lesson. Each question will take you a long time to complete, so make sure you're following along slowly. Make sure you listen to what I am telling you. Okay, so we're going to start off simple by telling you what is a conjugate. So a conjugates are the sum and difference of the same two terms. So, for example, if I have a radical 2 plus radical 5, then the conjugate of radical 2 plus radical 5, which is a sum, is going to be radical 2 minus radical 5. Here's another one. What is the conjugate of 5 minus radical 2? The conjugate of this is going to be 5 plus radical 2. Here's a third one. If it's radical 7 minus radical 3, then the conjugate of this will be radical 7 plus radical 3. So basically you have the same term, however, the plus and the minus will be the conjugate. Okay, so why do we need these conjugates? All right, so we need conjugates to rationalize the denominator. And here's the reason why. So you know that the difference of squares says if you have a sum times a difference, so a plus b times a minus b, the result is going to be a squared minus b squared. And you can find this out by doing actual FOIL on the left side. And this we have done in the previous chapters. So these two, this a plus b and a minus b, these are the sum and the difference of the same two numbers. So these are conjugates. And on the right side, because it becomes a squared plus b squared, these will no longer be irrational radicals. They will become rational numbers. And this is the reason why we use conjugates. So let's look at a few examples. Here's a simple example. Remember that the goal is to have no more radicals in the denominator. So how do we do this? So this is your initial question. So you're going to say, okay, it equals the same 3 over 5 minus radical 2. We want to eliminate the radical in the denominator. And you cannot just multiply by radical 2. Okay, so again, we want to multiply this fraction by times 1. But remember that 1 can have the same numerator and the denominator. So we're going to use the conjugate of the denominator, which is going to be 5 plus radical 2 over 5 plus radical 2. And now all of a sudden you have all this math you have to do. But if you do this slowly and carefully, you will get to the right answer. So let's do this slowly. So in the numerator, we have 3 times 5 plus radical 2. So you're going to do the numerator with distribution. And the bottom, because it's a difference of squares, you're going to get 5 squared minus radical 2 squared. Now take your time and do this slowly. So we have, I'm just gonna go all the way down. Here we go. So we have 3 times 5, which is 15, plus 3 radical 2. And in the denominator, 5 squared is 25. And radical 2 squared is just 2. So the numerator stays as 15 plus 3 radical 2 and 25 minus 2. Now this is your answer. However, sometimes you can simplify a little further, and I'm going to show you that in the next examples. Remember to reduce the fraction to its lowest terms, and this will become tricky in the next few examples. Okay, so let's try another one. Here is your next question. You may want to try this one. It's relatively easy, so pause the video and give it a try. Okay, here I am going to reveal it. So we have the same fraction. You're going to rewrite your fraction and you're going to multiply it by the conjugate over the conjugate. So in this case, the conjugate is going to be minus and minus. There is something I want you to do at this point. I want you to put parentheses around each one of these because they can end up becoming very, very confusing very quickly. All right, so my numerator, I am going to do distribution. So I'm just setting it up so you can see. And the denominator is going to be the difference of squares. So radical 7 squared minus radical 3 squared. And now I'm going to do distribution in the numerator. It will become 5 radical 7 minus 5 radical 3 over, remember, it's 7 minus 3. And now 5 radical 7 and 5 radical 3, these are not like radicals. So you cannot do anything more with them. So we're going to simply rewrite the numerator, and then in the denominator, we know how to do 7 minus 3. So the answer is 4. Now you need to look carefully at each term. There's nothing here that can be reduced. This 5 and this 5 cannot be cancelled out. It just stays the way it is because 5 radical 7 is a different number from 5 radical 3. All right. So here is your next one, and this is your last one for the day. This is super difficult. Make sure you are trying to pay attention. So what I've done is I have rewritten the fraction, and this time I put the parentheses in the denominator because it helps you see what you're doing. We're going to multiply this by the conjugate of the denominator. And the conjugate of the denominator will be the same two terms with the minus sign. And so in the next step, your numerator, you're going to do distribution. I've just set it up so you can see the distribution. And the denominator is a squared minus b squared. Now very slowly I'm going to reveal all the steps. So the numerator, the first term, becomes 2 times radical 8 times radical 7 minus 4 times radical 8 times radical 10. I've written the whole number in the front. And in the denominator, we have 2 radical 7 times 2 radical 7 minus 4 radical 10 times 4 radical 10. Now, very slowly, you're going to do each part, okay? So, equals 2 radical. I'm showing you the math. If you know how to do it faster, you can. And notice the denominator becomes 2 times radical 7 times radical 7 is just 7. And so 4 times 4 and radical 10 times radical 10 is just 10. So now we have 2 radical 56 minus 4 radical 80. And in the denominator, we have 28 minus 160. Now, radical 56 and radical 80 can themselves be simplified further. And this is something we did in the first day. You need to know how to simplify those radicals. So now we have the radical 56 is going to become 2 times radical 14. So it becomes 2 times 2 radical 14. And the 80 is going to become 4 radical 5. And the denominator, by now you should know that much math. And now here comes the very tricky part. So I'm going to do 4 radical 14 minus 16 radical 5 over negative 132. Now, this fraction can be reduced if every single term, the 2 terms in the numerator and the 2 terms in the denominator, have a common factor. And we're only looking at the whole number part. We are not looking at the radical part. So reduce the fraction by the common factor only if the whole number of each term has that common factor. And it turns out that the number 4 and 16 and 132 can all be reduced by the number 4, or they can be divided by the number 4. So instead of 4 radical 14, it's going to reduce by 4 and become just radical 14. And the fraction itself becomes negative because you cannot leave a negative in the denominator. Minus, this can be reduced by 4, so it becomes 4 radical 5. And the negative 132 can also be reduced by 4, and it becomes 33. And now all of these terms cannot be reduced any further, so you have finished your question. I want you to try homework and see how it goes. Goodbye.